Hey everybody! Welcome back to Northernlion plays Kerbal Space Program, where on the last episode I launched a satellite into orbit around Minmus, and then... Or not around Minmus, but like orbit further away from Minmus, around Kerbin, but I guess apparently forgot to save after that point, and as a result am kind of unhappy with myself, so we will... Pardon me, launch another satellite on this episode. Do I at least have the saved rocket? Which I believe I called Satellite? Satellite, high Kerbin orbit. Well, like there's, you see what I mean? Like there's one, am I losing my mind? I'm probably not losing my mind. I probably just don't understand the interface. Let me go back to the tracking station here. I'm confused. Oh, is it on the launch pad? So there was like an autosave on the launch pad. I understand. So we'll get a second crack at this. On our first crack, we had an encounter with the moon, which really slowed down our efficiency, without a doubt. On this one, we'll try to be a little bit more aware of the situation. Recall that pretty much all we want to do is get maybe two I mean, I suppose... I was actually... It was coming up with like a brain-dead idea there. I was like, we could send two satellites on one rocket and then just drop them like... you know, several million meters apart to try to get a good orbit going, but I don't think that that's actually at all a sensible approach. Instead, what we're going to do is kind of do another take at getting this satellite into a high Kerbin orbit, and then we'll see how things go after that. But theoretically, this episode should lay the groundwork for us to be able to communicate with Kerbin from Duna, assuming that Kerbin and Duna are relatively close together, which is not always going to be the case, obviously, due to, like, you know, planetary alignment. But that much of the time, while they're close together, we should be able to communicate, which is essential so that we can actually maneuver an unmanned probe to land at Duna and then transmit scientific data back to Kerbin. So this might be a little bit of, in terms of like the cliff notes of this episode, the episode synopsis, if you looked at this on HBO's website, you would be like, oh, this looks like one we can skip. This is a Dorn episode. But no, we're, take my word for it, we're gonna get some necessary foundation laid so that, you know, the world can be our oyster in the future here. I do also want to point out, like, dude, this rocket is so ridiculously functional. Like, it actually gets the job done. It can gravity turn. I mean, it's a little ridiculous. I will suggest and acquiesce that it does look a little bit silly. And now that I've done that gravity turn, I almost put myself into a terrible position there. Oh, we did put RCS thrusters on this thing as well, so it should be able to maneuver a little bit better now. Did I do that? I think I did that before the end of the last episode, which just makes the auto-saving thing weirder. But anyway, you know the drill. We learned on the last episode, finally, when you burn at apoapsis, it extends the orbit in the other direction, or at the other extreme, aka our paraapsis, which at this point is like well within the core of the Earth or something. So our game plan, effectively, is to get into a circular orbit around Kerbin, which is happening in, like, the weirdest way plausible right now. Or maybe this is the best way we've ever done it. At apoapsis, we're going to add a prograde maneuver. They're actually, like, equal. If we do that maneuver 100%, we're going to be equal. Now, mind you, I'm supposed to burn 4:57 seconds in a minute. Now I only have to burn for 29 seconds? That doesn't seem right. The problem is... Oh, you know what? We should have just turned RCS on. Did we put any monopropellant on this thing? We didn't put any monopropellant on it? That's a little silly. Anyway, in a couple of seconds, we're going to start this burn. It's probably not going to be exact, and I think that's okay, because, you know, to thine own self be true. as I always say. Now, we're up here in space, you know, deploy the Airstream protective coating. Now we've got like an actual satellite here. It's a pretty hideous rocket. You're probably looking at this rocket and going, this is a stupid rocket. It's not even like at all aerodynamic. Yeah, well, guess what? It doesn't have to be aerodynamic. It has to be spatiodynamic because we're in outer space. You joker. Anyway, full throttle, please, and then not on prograde, but rather on this marker. More than enough fuel to tackle this, but this is only the first step of getting into a high Earth orbit. High Kerbal orbit, to be more specific, I suppose. Remember, we can slow it down a little bit. Minimize the risk that we're going to overshoot this here and maximize the amount of tolerance that we have. And I hope that this time we don't encounter the moon by accident. Again, I would... At many times in my Kerbal life, I would have killed to accidentally get an encounter with the moon or Minmus. This is not one of those times. Slow. Good. Maneuver done. Periapsis of 81, apoapsis of 652. Well, we managed to mess that one up pretty nicely. It also, temporarily it looked like we might collide with that satellite, but it appears that we will not. So I'm thinking, why don't we just make it so that at first we get a nice, like, extremely distant orbit. Like this just to minimize the amount of maneuvers we're doing. And then at the apoapsis of like 60 million, we'll burn prograde again. Without escaping. We've got a periapsis of 52 million and an apoapsis of 83 million. It's unnecessarily non-circular. 59 million, 75 million. That might be a little bit more appropriate. Oh, so in T-minus 20 seconds, we're going to burn for 21 seconds. That's my bad. We should still roughly be on point for doing this maneuver, though. And this way, we only have to do 2 maneuvers. You know, we do one burn here that extends our apoapsis in the, let's just call it the A direction. And then at the apoapsis in the A direction, we do a burn at prograde, which will extend our vector to be more circular so that we actually get better coverage around the planet. So this seems like good to me. I wish we could just automate this process, but, you know, 6 months apart or something. Probably not 6 months. No, we might have chosen, like, literally the worst. Well, I guess it depends on the speed of the orbit. It's going to be much less than a 6-month orbit, I assume. So this looks lovely to me. 48,000, 66,000. I can live with it. In 10 days, we're going to burn for 6 seconds. I would say that we definitely have enough fuel to accomplish this. That's pretty cool. So, I mean, we'll just... I guess step 1 is get pointed at the maneuver node. Okay, we shouldn't burn because... You know, we only have to burn for 6 seconds, so even like a slight burn does nothing for us. This thing needs monopropellant, though. So we'll get to work on that. I don't know if I want to go 100,000 speed. It seems incorrect. 6. And 5. And 4. And 3. And 2, and 1. Okay. Maybe 1,000 speed? 100 speed? 100 speed. 1,000 speed. Playing with fire a little bit. But again, I think it's a pretty coarse burn. We're not trying to land on a planet, we're just trying to establish an orbit in a certain circumference around the planet. Should be relatively simple. So we'll stop this at roughly 1 minute. And then for our next launch, we'll definitely throw some monopropellant on. And I guess, I don't know, can we just, like, slow the launch down? Or slow, like... I guess once we get into orbit, if we're on a similar sort of orbit, we could just burn retrograde for a while to slow ourselves down. Is that correct, even? Please, just a mild sort of burn here while I seek to get on to the maneuver node. Yeah, that's working like gangbusters so far. Well, really, we're just going to be burning prograde at this node. Whatever, dude. This'll work. Now I realize that I'm a mild idiot because we need to burn like a little retrograde. Just to make sure that we don't get too far away. And we've also accidentally gone like way over the surface. Like we've created this weird non-circular orbit that makes me a little upset. But you know what? That's lesson learned. We definitely should have just burned at the maneuver node instead of being, oh, I'm like a big old Stephen Hawking kind of scientist, man. But there you go. So there's one satellite in orbit. It's a bit of a strange one, but I mean it's far out. Now where's my Duna at? Right over there. Apparently in vanilla Kerbal Space Program, the tolerances for like network transmission are relatively high. So, you know, there's a good chance that we can communicate with this network, I think. So we're not going to revert flight. Just take me back to the tracking station. There's our high orbit satellite there. Can we can like issue maneuver nodes, or is that a maneuver node that we missed? Because I don't really want to do this one anymore. Either way. It still has fuel, so we'll leave it up there as a potential collision hazard for the future. MET, is that like... I don't know what MNV means. Does that mean it's too distant? You know, that's probably something that we should look at here, like MNV KSP meaning. Terminology. MNV. Oh my god. What about MET? Well, what does the color of the MET mean? Look, that's something we can learn in the future, I suppose. For now, no, do not terminate. This is a very important step in theory. We're gonna go back to our vehicle assembly building, and on this same rocket, really anywhere protected up here, I think we should just give this some freaking monopropellant tanks. I don't know, like 4 might be overkill. 4 might also be like very underkill. But that's how it's gonna be for the time being. Yeah, let's just go with that for now. So essentially we're gonna do exactly the same thing, which is why I said it's gonna be a little bit of a samey episode from that kind of context. But now we actually have some monopropellant. 240 units of it. And mostly, I'm high on life, dude. I'm amazed that we actually have the ability to execute a gravity turn. And not even like a crappy gravity turn. Unless, you know, let me put it this way. If the gravity turn is crappy, it's like user error. So the goal, I recognize I kind of... It's getting a little wibbly-wobbly there. I recognize this is kind of rich after messing up the orbit of our last one. But the goal here is really to have all of our satellites on the same trajectory, but 120 degrees apart from one another. Now, that pipe dream is not going to last, because our orbit for the last one is really messed up. We could try to match it, but I think I'm just going to aim to get into a similar orbit, but behind it by a little bit, and then see what happens. But actually, like on this one, I've already, like, I don't know, I think I went overly aggressive with the gravity turn early. I know you're probably going, you think? But, you know, we got quite the extension on this vector right off the bat. No one can deny us that. Did get a little collision off the fuel tanks. Is it like hydraulic manifolds? Did they push things further away? Like, do they have more explosive force when they pop? Because if so, those might be more useful on this. Well, you got quite the little wibble wobble going on here. So we're taking a much, much longer time to escape from Kerbin. On the other hand, we should theoretically be spending way less fuel once we reach apoapsis to get around the surface of the planet. So we're not on what I would describe as a planar orbit, which is a word that I don't even know if it means what I think it means, but I think you know what I mean, and that's the important part. It's not like a belt around the surface of Kerbin. Rather, whoops, well, now we need a little more. Rather, it's on a little bit of an angle, you know, but again, to some extent, beggars can't be choosers. Get us prograde here. Well, we'll turn RCS on in a second, but for now, add maneuver, pull it out, get it as circular as is reasonable. 86,000, 360,000, 84,000, 97,000. I'm going to take that as being acceptable. I'm going to turn RCS on. And I'm going to have it turn me towards the prograde. But I'm then going to put on stability assist and have it move me like a little bit more towards the maneuver node, as you might expect. Also, destroy the fairing, please. Get that out of here. Is there any way... Do you use, like... People have told me to use reaction wheels instead of using monopropellant tanks. Like, reaction wheels might use electricity for balancing or for stability. I'm not sure if they can maneuver you with as much finesse, I guess, is what I'm trying to suggest. Maybe, maybe not. But I guess the simple question that I'm trying to ask and get an answer to here is, could I use inline reaction wheels to accomplish a similar thing, only using electric charge instead of having to use monopropellant? Because in that case, we could just put batteries in it and, you know, photovoltaic panels, etc., etc. By the way, these things do have photovoltaic panels, yes, okay. Because I need them to recharge the satellite power. Hopefully that works anyway. So our burn is going fine for now. I think we're just about... We're either going to be out of fuel in our outer stage tanks, or we're going to be close to it by the time it finishes. I think we're going to be out by a little bit. Yeah. Just be cool. Again, this might mess up the circularization of the orbit, but I'm okay. No, that's as good as it gets. Starring Jack Nicholson. Close it out. Okay, periapsis 75. Kerbin apoapsis of 111. So again, if we want to do two maneuvers, I think the way we do this is our first maneuver, we'll do it at apoapsis and make our other apoapsis like this. And then at this apoapsis, we'll add a maneuver. Oh, we had an encounter there. Please no. And do something like that. That's too far. Do something like this. I want to kind of slow it down a little bit here, because if I go much... I don't want to get it wrong and accidentally have an encounter, and I don't want to get it wrong and accidentally... You know, if I, like, burn slightly incorrectly, oh, sorry, now you're in space forever, you know what I mean? So this one looks pretty swell to me, actually. Right about here. 82,000, 56,000. All right. So we'll be burning roughly at the prograde mark in 8 minutes. Oh my god, that's in like no time at all here. So let's put on stability assist and RCS. We still have quite a lot of monopropellant. We'll work our way over to the maneuver node, which is like weirdly also aligned along the normal here. We've used about an eighth of our monopropellant. I'm not that worried about it. Because we only have 2 maneuvers, I don't really think that that's an overly, like, outrageous use of monopropellant so far. We're going to go times, like, 50 speed very temporarily. Okay, so at about 18 seconds remaining, we're going to burn. 37 seconds is not an insignificant amount of time to have to burn for, admittedly. And at this point, again, we're pretty much just sticking on the prograde marker, so just put it on that for now. It's just easier than having to deal with micromanaging the maneuver node. But we'll put it on prograde and then switch to stability assist, so that, as needed, we can kind of issue changes here. Just focused, 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 focused. 1 and 0, and we're good. Okay. Within tolerance levels. All right. This maneuver node now has us leaving the surface, or the sphere of influence of Kerbin. So we'll add a maneuver here. Just do something like that. I'm fairly pleased with that. Oh, until then. I'm fairly pleased with that. I don't like that we got one going like this and one going like this, but I don't know, maybe that's actually a good thing that we've got them essentially like diametrically opposed relative to their own axes, and I don't know. Again, that could be a positive for us, or it could be a terrible negative is the other alternative. But I'm just going to stick with this for now. And honestly, I might try to cap off this episode with an unmanned flight to Duna. With the hopes of us actually being able to, not to land on Duna this episode, because we're already getting pretty deep into it, but the idea would be for us to see if we're able to transmit with as far out as we would have to be for Duna, you know? And that, again, might involve warping several hundred days in the future, perhaps? Can I ask you a question? Why are you not aligned prograde anymore? I have to assume that it's due to the, like, weight distribution of our ship or something, but I don't know. Like, just take a day, use your RCS, and, like, get aligned prograde again, please. And Kerbin is, like, quite a distance behind us. There it is, right there. What, of course, I meant to say is, here am I sitting in a tin can, far beyond the world. Planet K is blue, brown and green and yellow too. Gonka donka donka gonk gonk. You're not really staying aligned on the prograde. I've got to be on the level with you there. I really wish that you would... I guess you can't apply force if you're not in real time, so I understand where you're coming from here. I may not respect it, but gosh darn it, I respect it. Probably the worst joke in the Northernlion oeuvre. What are you doing, Susan? Judging oeuvres. Cooking oeufs. Oofs. Okay. Use your RCS. Position yourself along the prograde. And then, I mean, we could detach this thing, but I feel like while it has fuel, we might as well not detach it. Because we might end up needing that fuel, or needing is a strong word, because there's no men on, you know, women on these ships that we need to bring back to Kerbin. However, we might end up wanting to bring them back to recover the money. Let's be honest, we're never going to do that. On the other hand, why not adhere to a best practice just to show that we're trying, you know? So we messed it up. We're probably flying into space a little bit. We are flying into space, so we'll do the obvious here. Turns out 4 cans of monopropellant, 4 tanks, rather, is probably a little bit overkill. However, it also did give us enough. And it gave us, well, about what we needed plus a half. Which might be a good factor just in case we royally messed up a maneuver or something. So we're getting decent, I would say, at, you know, putting these... Oh, what, do we have science in these? What did I put in these? Batteries, that's right. Getting pretty decent at, you know, putting these satellites up here, even if the orbits are all sorts of messed up. We should probably, if I'm being honest with you, should have seen that coming. There you go. 47,000, 72,000. I don't like how it's declining. Now it's going up. Now it's stopped. Now it's going back down. I don't know. Maybe it's because it encounters something along the way. It shouldn't, though. It's far enough away that I don't think it should. Wrong way to do that. So now you should stop being an idiot, point prograde, and then burn a little bit. Just because I never want this orbit to intercept Minmus, because eventually we're going to get put into orbit, we're going to get put into Minmus's sphere of influence, and then that, you know, resulting butterfly effect could end up with this satellite being launched into outer space, or rather, it might end up in orbit around the sun, which is probably irrelevant for us, or it might end up, you know, crashing into Kerbin or something like that, which would probably infinitesimally small odds, but maybe not. I mean, it could just, even if it gets captured by Kerbin, it could just be on such a, you know, bad orbital trajectory that it crashes into the planet to begin with. So it's going to burn, like, ever so slightly. And now we're going to burn retrograde for a minute. I recognize I am a moron. I would like that to be apparent right off the bat. So I'll tell you straight up, we're probably going to end the episode after putting this satellite up. Again, as expected, a little bit of a transition episode. Next episode, we're going to try to fly to Duna. Now, what do we got? We got one satellite going whoop-de-whoop-de, north-south. We got one satellite going whoop-de-whoop-de, east-west. The problem is, like, it looks like we got them in great distance, but Duna is still quite a distance away. So we've really only very, very slightly increased the transition range, or transmission range, I should say. But it's probably, even if it doesn't make a difference, I think it's the right idea. And to some extent, I think that's important. I think it's important that we're setting up the facade of having a real functioning space program. So sure, you know, maybe these satellites aren't going to take us to Mars, but at the very least, or maybe we can get to Mars without them, but at the very least, people are getting satellite TV. They're getting images of the moon, you know? I'm happy with this. It might not be perfect, but it's ours. So for now, thanks for watching. I hope you guys have enjoyed this episode. We're going to try an unmanned probe to Duna on the next episode, despite what I'm sure is going to be lamentations in the comments, like, you can't make it that far. You're probably right. But for now, thanks for watching. Duna's still pretty close. Like it said, if you're at 3, it should be at 130, which roughly looks about where we're at right now. So I'm going to give it a shot next episode. If you enjoyed this episode, first off, thank you. Thank you for your enduring support of Kerbal Space Program and our quest to get to Duna. Click the like button if you enjoyed the episode, and of course subscribe if you want to see more in the future. The future for now means tomorrow, and I'll see you then.